Welcome to today's explainer. You know, I am absolutely pumped to have you here today because we're about to dive into a massive paradigm shift in how we approach engineering calculations. For decades now, we've basically just relied on fragile spreadsheets and static textbooks, kind of accepting all this hidden friction as just part of the job. But today, we're leaving all of that behind. We're going to explore the vision for what we call unit freedom, a world where we finally escape the trap of manual conversions and get back to pure engineering physics, all based on unit-aware quantities and unit-agnostic formulas.
Okay, let's kick things off by looking at a pretty staggering number: 125 million. Specifically, $125 million. That was the exact cost of the NASA Mars Climate Orbiter, which, as you might remember, was a spacecraft lost entirely in space due to a single misplaced unit conversion bug. Literally, one team was working in metric units, another in imperial, and because their software couldn't natively bridge that gap, a $125 million piece of hardware was completely destroyed.
And that really brings up a highly provocative question for us. How many hidden unit bugs are sitting in your team's static legacy spreadsheets right now? Think about it. We're engineers. We shouldn't be acting as human calculators doing manual bookkeeping for seconds, minutes, watts, or horsepower. Yet, we've somehow just accepted these massive, relatable pain points in our daily workflows. We essentially live in constant fear of someone changing a single cell from millimeters to inches and just completely breaking the entire mathematical model.
All right, let's jump straight into Section 1. Exposing the magic numbers, the villains of engineering math. Let's start our investigation by exposing some of these quote-unquote bad habits that mechanical, electrical, and robotics engineers have blindly accepted as laws of nature. Because, in reality, they're just human translation errors. Take a look at our first villain, 5252. If you've ever calculated rotational power, you definitely know this magic number. It's the imperial horsepower constant. We constantly copy and paste this into our spreadsheets. But peeling back the curtain, this isn't a law of physics at all. It is really just a messy collision of imperial units, mixing up radians per revolution and foot-pounds per minute, just to force an output in horsepower. If you accidentally input torque in inch-pounds instead, your calculation silently self-destructs.
Now you might be thinking, well, I use the metric system, so I'm safe. Interestingly, even the supposedly clean metric system falls into the exact same trap. Meet 𝗨9,550. Engineers use this number to convert rotational speed in RPM and torque in Newton meters into kilowatts. It is literally just baking the conversions of minutes to seconds and watts to kilowatts directly into the physics. The fundamental law of physics is simply power equals torque times angular velocity, but our legacy tools force us to clutter it up with these totally arbitrary constants.
And it doesn't stop at mechanical engineering either. Over in fluid power, 231 is the classic hydraulic trap. If you want to find flow rate in US gallons per minute using displacement in cubic inches per revolution, textbooks will tell you to divide by 231. Why? Simply because there are exactly 231 cubic inches in a US gallon. It's an arbitrary geometric constant that's forced into flow rate equations for one reason. Our legacy spreadsheets are completely blind to actual units.
So the crucial takeaway here is that this is a universal pattern. Across mechanical power, hydraulics, and electromagnetics, there's always a fundamental law connecting a linear or scalar quantity to a rotational one. The pure physical laws, which you see in that middle column, are beautifully simple. But the trapped reality column shows what legacy tools actually force us to do. Bake in time, volume, and revolution constants. We're systematically relying on human translation workarounds instead of just using unit-agnostic physics.
This brilliantly illustrates the contrast of simplicity in, simplicity out. On one side, we have the cryptic, incredibly fragile cell references of a legacy Excel spreadsheet. To get angular velocity, an engineer has to write out equals 2 times pi times cell D10 divided by 60. That divided by 60 part, that's a hard-coded nightmare waiting to happen. On the flip side, we have the unit freedom way, using an interactive environment like CalcSlive. The equation is just pure physics, omega equals 2 times pi times n. Absolutely no magic numbers required.
Let's formally define the core vocabulary of this new paradigm, starting with unit-agnostic formulas. These are mathematical equations written exactly as you'd see them in a physics textbook, completely free of hard-coded conversion constants. You literally just write what is in your head. The user writes one universal formula for rotational power, and it's mathematically true across the entire universe, no matter what units you happen to feed into it. Now, unit-agnostic formulas are only possible because of our second definition, unit-aware quantities. This is where the software acts as an atomic-level unit carrier. It inherently understands physical dimensions and geometry on its own. Because the software natively handles all those cross-conversions in the background, you can seamlessly change metric inputs into imperial outputs, like, say, feeding it Newton meters but asking for the answer in horsepower without ever breaking the formula itself. Moving right along to Section 2, the radian blind spot, a foundational SI flaw.
Let's dig into a deeper architectural problem in the engineering world to see how this builds our understanding. We really need to talk about the massive blind spot lurking under the hood of the International SI system itself, the dimensionless radian. Because standard SI rules treat the radian as just a dimensionless number 1, standard dimensional analysis creates a total paradox. Think about it. Torque is a rotational vector mathematically tracked as Newton meters per radian. Energy, or work, is a scalar value tracked as Newton meters, but because legacy math engines flatten the radian completely out of existence, a scalar energy value and a rotational torque vector look absolutely identical to the software.
And this missing structural intent creates incredibly dangerous landmines in modern cross-domain applications. Imagine an engineer sizing a complex J2 robotic joint actuator. You've got mechanical engineers tracking gravity torques and electrical engineers tracking motor thermals. When they try to actually connect these systems, dropping the radian out of dimensional analysis means the software cannot inherently verify if an algorithm is confusing rotational effort with raw scalar energy. It causes these silent calculation bugs that traditional tools simply cannot catch.
We see the exact same flaw over in electromagnetics. In a permanent magnet motor, the torque constant, Kt, and the back EMF constant, Ke, are physically identical through the conservation of energy, so Kt equals Ke. But catalog specs list Ke in volts per 1,000 RPM, while Kt is in Newton meters per ampere. Because standard code flattens the radian out of existence, traditional software sees these as identical base dimensions, completely missing the fact that a calculation might actually be off by a factor of 2 pi or 60. Just to highlight one more SI legacy landmine for you, symbol collisions. In standard metrology, the capital Greek letter theta is used for thermodynamic temperature. But in actual everyday engineering, we pretty much universally use theta for angles. In digital code, this creates a totally unnecessary namespace collision. A thermal script and a kinematic script placed side by side are just going to clash. It really proves that legacy standards, which were designed for chalk on blackboards, absolutely have to adapt for modern digital automation.
Which brings us to our final part, Section 3, the unit freedom vision, simplicity in, simplicity out. So how do we actually fix all of this? Let's introduce the resolution to our mystery. It's time to shift the cognitive burden of dimensional integrity entirely off the engineer's shoulders and place it exactly where it belongs, onto the software. That is the unit freedom vision. The workflow in a unit-aware system like Calc Live is an elegant, totally frictionless loop. Step 1, you just input the pure physical law. Step 2, the software handles all the atomic bookkeeping and dimensional analysis right there in the background. And Step 3, you get a beautiful, interactive, and completely robust output. You can literally just toggle an inline dropdown to change from liters per minute to gallons per minute, and the underlying system completely protects the math. To summarize exactly what this achieves for us, it completely eradicates those magic numbers like 5252 and 9550. It treats the radian as a real structural carrier under the hood, effectively curing a multi-decade flaw in dimensional analysis. It lets us safely couple rotational and linear mechanics without all those hidden traps, and it actively catches unit mismatches before they break our models. You literally never have to memorize a conversion constant again.
I want to leave you with a quote that really hits the nail on the head and embodies the entire philosophical mission behind the unit freedom movement. It goes, "Let the software handle the units. Let your engineers focus on the physics." We shouldn't have to spend our lives acting as manual translation layers. We're engineers. We should just be doing the physics.
And finally, I want to challenge you with this thought to chew on. Which world does your engineering team spend 90% of its time in right now? Are you stuck in the fragile, hard-coded world of legacy spreadsheets, battling magic numbers day in and day out? Or are you ready to explore true unit awareness and simplicity? Think about it, and let's keep pushing the boundaries of how we build the future. Thanks for joining me on this explainer, and I'll catch you on the next one.